Hello. So, today we're going to continue working on trying to get our procedural macros working on stable. So we had a kind of sort of semi-working macro form of insertable into yesterday. The thing I forgot is that insertable into supports tuple structs, and we really didn't quite go through all of the cases that I think we need to support. And in fact, the approach that we took was sort of fundamentally flawed if we're going to also support tuple structs. Specifically because we focused on building up this expression out of accessing the fields of the struct directly. But for tuple structs, we're not going to be able to do that because the fields are indexes, and B, even if we it can be a pain to do tuple access in a macro. But even if we had those, if we want to have this work by people copy pasting the struct definition in, we won't actually have access to those. So what I've instead done here, this is sort of what I'm imagining the quote-unquote bottom of the macro being. So this will be the thing that ends up getting called by everybody, or every other case at the very end. So I've broken it down into what we absolutely need. And the big thing that's changed here is this expression is now no longer focused on how we access each of the fields, but is instead focused on destructuring self into local variables that have the same name as each of the columns. I was mildly worried that hygiene might get in our way here, because technically the pattern will have a different identifier than where the column name comes from, but everything seems to be fine there. I did test that out. And I've sort of spiked on this a little bit and looked at how to get the how to get a tuple struct working with it, and I haven't migrated anything else over to it, and I even deleted the tuple struct case because it was a little messy. So I'd like to take a bit more of a methodical approach to this. And I opened up an issue yesterday. I'm gonna pull that up in another window here so I can refer to it, because I've got a little checklist of just all of the various ways in which a struct definition can vary. And so I'd like to just write an explicit test case here for all of them. So I should mention also how tuple structs would work with all of this. So if you are annotating a tuple struct with insertable into, what you'll have to do is annotate. So let's say the users table has a name column, which would be a string, and that has a hair color column, which would be an option of string because it's nullable. So what you have to do here in order to use this, because we need to know what column this is associated with, so you have to annotate each of the columns with column name equals name, and here it would be at column name equals hair color. And usually for insertable, we tend to use borrowed data because you don't tend to pass these things around very far. So this is what it might look like in Diesel 0.6. Now, one of the things when we're looking at doing this with just a normal macro and not a procedural macro, we can no longer we can't actually match the right-hand side of this type of annotation. So we're gonna have to change this. So I've got a pull request open that I think is already ready to merge, but that basically changes the procedural macro to work like this. And I prefer the other form a little bit better. I think it reads more clearly. But if we want this to just work without procedural macros, this is what we have to do. So that's fine. And other ways that might vary, there may or may not be pub in front of each of the fields. The struct itself may or may not be public. There may or may not be lifetimes. I also want to test for things like if there's an additional annotation on here that's like, can we just do true there? I don't think we can just do true there. I don't know. Like, we'll do feature equals Postgres. Something that, like, some sort of attribute that Rust won't yell, Rust won't complain about being unrecognized, but that we can have, like, that we can just have there that won't affect the struct definition and will just be a random attribute. Because we need to test to make sure that we still properly match this. So those are all, like, all of the various cases, and then we need to do all combinations of those with named structs as well. So sorry, I'm just trying to collect my thoughts. I'm a little out of it this morning. So we just need. I want this to be. I'm not necessarily. Oh, we got a question in chat. Is there any indication of how long it will be before whatever you're blocked on with procedural macros will be unstable? Curious how much time you should be putting into this versus letting that all start working in however many weeks. So right now the roadmap looks roughly like improving the story for syntax is going to happen sooner rather than later. I don't know exactly when, but probably in the next couple months. libmacro will probably take quite a bit longer. Regardless of whether or not those are stable, though, there's a couple of specific things that we can do in a regular macro that we couldn't in a procedural macro. And the biggest one for me is we're referencing diesel by name here. When we move this into the main diesel crate, we can change that to $crate, which means that this will still work if you rename diesel. And the goal is to have the procedural macros just call this macro directly, but parse things out and give better error messages, and still have the procedural macros work. As for how much time to spend on this, basically, my goal is to get us my goal is to get diesel ready to go to 1.0, and that means I need to address anything that I expect to have breaking changes. This is one of those things. We've already had one come out of it in the format of column name, and at the end of the day, some people just aren't going to want to use syntax extensions, and I would prefer that we have a reasonable story there. So I'm not saying I do want to make this macro compatible with the custom derive crate. I don't know that. I don't know that I want to specifically like recommend or enforce that crate, but it seems to be a decent pattern. And so the way that crate works is basically you create a macro with the same name as the thing that you're deriving. If it takes any arguments, they'll be passed within parentheses, followed by just the entire struct definition with all of the attributes. I don't remember if it strips out the attributes or not. That's actually a good thing to check. It will include all of its attributes. Now, one thing to note, and I actually need to. I'm planning on looking and seeing if there's been an RFC for this. So, the way that this would work with the custom derive macro, so we'd do something like this, and we'd say derive insertable, and then this can take arguments as well. So it'd be this as opposed to our insertable into users attribute that we have now. And I actually kind of like this. This feels just more consistent because insertable into is custom derive, like quite literally. And then we do pub struct new user. So if we wrote this, what that crate would do is our macro would get called. So well, actually, I'll show what it does. So it would call insertable like this. And then just the entire struct definition. And I'm actually not sure if it strips this or not. It looks like it doesn't. And then basically it's up to, and we'd probably have these fields be public, I guess, right? So then we get that. And this is where it gets a little tricky because then it's just up to the macro to actually parse the struct definition correctly. And there's just a lot of weird variants. Some of them I'm just not going to handle. Like, I'm just going to not deal with if you don't want a trailing comma because I'm just not. But yeah, so basically what we're gonna do is I'm gonna write a bunch of test cases, and then we're gonna have it, and then we're just gonna add a bunch of additional cases to this macro that parses down the struct and separates out the table name, which that is always really easy to do because that's just the first argument. The struct type, which is also again always really easy to do. Any lifetimes that it might have, any what the actual values type is, which this will probably pull out a separate macro that, given all of the parsed column definitions or field definitions and the table name, generates the proper values type. And then the pattern that will destructure into the fields into variables with the same name as the column, and then a list of all of the columns, both the name and whether or not they are an option. So let's start. So we're gonna just create a custom table here. I'm trying to think if we actually, when we establish the connection, because this matches what we have in our migrations, but I might just create the table inline anyway. I'm just going to assume SQLite for now. We'll deal with other backends later, or we'll deal with Postgres later. And I think we need to unwrap that. So let's just start with the simplest case. So we'll have no modifiers of any kind. Let's do use self users DSL star, so I don't have to prefix everything with users : : and I'm just going to ignore the ID here. Right, so we'll just, and this is what most of the tests will look like, because we're not actually really testing much about insertion behavior. We're testing that this struct, that this macro generates the right thing given a struct definition. So we will define a bunch of different structs, create one instance of it, save it, and test that the data went in. One thing I am going to just do now is I'm going to change hair color here to have a default. And the reason for that is once we get, I'll do that later. But once we'll do that once we get to option fields, so that we can test that it actually passed it as the default value and not inserted null. Which right now, when the default is null, it's impossible to distinguish between those. And when we're not dealing with option fields, well, then we'll just always have a value there. Okay, so the first one that we'll address is macro undefined table, and that's just because we need to move this down to the bottom. So the macro gets defined before we are compiling that module. And I guess we also need to move query builder, because that has a macro in it before macros, because the table macro calls impl query ID. When we're calling table from there. No. Crap. I'm just going to move the macro definition for query ID down here into the macros module. So that means I can get rid of that. Can move this back to like here, as I sing the alphabet song in my head. I cheat Atlin. I'm not going to be adding MySQL support to the main Diesel crate. It is designed to support third-party adapters though, pretty easily, and I'm not positive if anyone's actively working on a MySQL adapter, but I'm happy to help anybody who's interested in it. But I'm not planning on adding that to the main crate. Okay, so now we're getting the failure that we wanted. Okay, so we're going to be taking, oh, and I need to pass this like this. Okay, so we're first going to take the table name, followed by struct, and we will have at least one field. Is that everything? That is everything. So the table name is, well, so this is what we're going to need to finally do. Insertable. Let's just see. We're not going to have everything yet, but this will change pretty wildly as we get to handling options, but that's okay. This will be something like struct name and I know that I don't need the col. Well, you know, I'll just leave that for now. We'll eventually change this as we start to handle columns with different names than the field. And then for the value type, we're going to take, what are we passing in? We're passing field. Oops. Field name, which is an ident. Let's call this column name, actually. Field type, which is a tie. And we'll just return unit. Still no rules expected struct. Oh, there we go. No rules expected the token open paren. And that's coming from 18. That's because we forgot a semicolon. Field name is still repeating at that depth. That makes sense. Macro undefined parses item. Actually, no, it's fine. We'll maybe move that around because I'll probably need that for the other ones as well. This is just a little workaround for the fact that since we don't have the lifetime matcher yet, we're having to match against it as a token tree. We have to do this little hack. That's all it is. I'll need to remember to macro export all of these at the end. Type macros are experimental. Right, crap. Okay, this is fine. Let's do this. I'm gonna grab some of the macro code for, that's wrong. I'm gonna grab some of the macro code from yesterday that we were using to create that type. Where the hell is it? And what we're going to do is we're going to delete this. Let me move this so you can see what I'm doing. Instead of taking the type, we're just going to take the field type here. I'll call that field kind. And this was the code for values type. And field name here is going to change to column name. I think that's the only change. And just to be consistent, I'm going to call that tie instead of type. Tabarja, I am on nightly from like 3 weeks ago. A non-variable field type. And I am going to just grab this from the code from yesterday, because that is not going to change at all. Well, it will change some, but I'm still just gonna grab it. And what did I just call that? Insertable column expert. So this becomes, so column's fine. Column name is now expert is still fine. Actually, I can still just call it field access. I don't actually have to change this at all. I do have to change this. Insertable. Yeah. Ambiguous associated type. Oh, this is because I can't do that. I need the users module to reference the users module. Just do it here. Most of our like important functions are re-exported at the root of the crate, and then we have a prelude module that we recommend you glob import, but we don't recommend you glob import the root unless you don't mind us putting rather generic function names in the global scope. Or global's not the right word, but you know what? I'm just gonna do that. Do I just need... Oh, well... So what I need to do is put an ampersand here, but then as soon as I do that, it's going to fail because we're trying to move out of borrowed content. Hello, HMOXO. How are you this morning? / evening, depending on what part of the world you reside in. It's compiling. I would have expected that to have failed. There we go. Yeah, so I just need to delete this, and then in the pattern, I need to have this be ref. I'm doing about as well as one can be doing when working on obscure macros. Just me, or is this taking longer to compile than it did than it did yesterday? Yes, I do have a YouTube channel. It's just /C/Sean Griffin. And it's basically just it's all just the VODs from this. Okay, so that works. I don't expect, until we get to option, I don't expect any of these to fail at runtime. I only expect them to fail to compile. Let's go ahead and get one that will fail at runtime. Whoops. Come on. And then we're going to expect green here. This is what I was mentioning earlier, because right now it's doing the wrong thing. It's going to actually try and insert the value null, but what we actually want to do is use the default value. But when the default value is null, we can't differentiate between the two. So we'll just default it to green, because people by default have green hair. It's a very common hair color. And I don't think that we're going to do like every permutation of every combination of modifiers here, but we will try and be pretty exhaustive. And I'm going to see if something else is using my my CPU more than it should be, because this is taking longer than it ought to. Kernel task is awfully high for some reason, and then Chrome is too. Do I have any additional Chrome windows I'm missing? Oh well. Alright, so there we go. Our assertion's failing. We expected to get green back, and we instead got null back. So now we're going to have to do that same thing that we did yesterday. Where we just take the body as a series of tokens. And then parse them individually. And I'm going to pull some of that code out from yesterday, actually. That's the wrong branch. So this is going to be something like something like this. So we took all of this. And actually, does it need any of this? I don't think it needs any of that. So we'll put this in a separate token tree. So that way it can be like, did I put a comma there? Yes. And then table name. No, I didn't take table name. Then I just took the body, right? Yeah. So what we did here was we oh, and let's go ahead and do fields equals an empty list. I guess this can just be prefix or headers. I like headers better than prefix, and that's a single token tree. Fields equals however many we've parsed, and that will be some number of token trees. And then the body is going to be so what are we looking for? We're looking for field name, field tie, and then just still tail. We're just going to call insertable parse columns again with the same headers, the same struct name, all of our existing fields. And then an additional token tree that is we'll say it's like a tuple, because that's how we're taking it. Column name, field type, field kind. I'm going to name these field, column name. Or we'll just continue to have that be field name, because we're not actually separating column name out yet. And then for the body, we will pass it the rest of the unparsed body. And then we're going to do the same thing, but without the option. Whoops, regular. And then we're going to do one more of these when we have nothing left to parse. So we take the field name, field tie, and I'm just making sure that we pass everything in sort of the right order. Table name, struct tie, lifetimes, self to columns, columns. Okay. And that's, so in this case, right, we're done parsing the body. So now we're going to actually do this. But we are going to split these out now. So I'll pass the table name, struct tie, and lifetimes. Self to columns is now all of that. And then columns is all of that, but this becomes field kind. I'm sorry, I am working on the lower left hand, or the lower right hand side again. Cuxy, that is roughly what I was doing. And then I just need to remove the parentheses at the very end. I mean, I could wrap them in parentheses on the other side as well. Forgot some commas. Probably don't strictly need the commas, but I prefer to make this look somewhat like an actual syntax. Uh, 167. Nothing expected. What? Am I doing something really dumb? It's complaining about the colon. the heck were we doing in the original one? That looks friggin' the same. Not what I wanted. There we go. That's very strange. It's getting to hair color, and that is, or the colon after hair color, and that is the place it doesn't like. And I'm pretty sure it's not anything to do with this parse columns macro that's failing. I'm pretty sure it's this case that's failing, because it would show us that it was multiple levels deep otherwise. Yeah, Cuxia, I started, after the stream, I started to realize what a lot of it was doing. I learned a lot about macros from examining that code. Huh. Well, okay, so let's trace this then. Yes, I mean, I've read it in the past, but I really started to read through it more heavily again, and yeah, it's a good book. Okay, so it is calling parse columns. So, if I'm reading this correctly, it's getting hair color, which is a token tree, colon, which is a token tree, and string, which is a token tree, followed by comma colon. So I am accidentally passing an additional colon somewhere. Oh, here's the problem. Haha. Nailed it. Yeah, normally you get a much better, a pretty useful error message when you forget to remove the colon TT, but it doesn't work so well when you're just parsing token trees. Okay, that's fine. I'm just going to remove the option there. I couldn't remember if we were going to do that or not. Cuxy, do you happen to know if proposing the derive with additional arguments has ever been proposed for the language? Because it would be nice if the custom derive macro were actually compatible with what the actual syntax extension form does. And I was going to write an RFC if it hasn't been proposed, but I wanted to check. Okay, if you want me to not write an RFC, then I can also not. Cool, so our test passed. Alright, so now... I kind of... I kind of want to move this test definition into a macro or something. Just because, like, the body of the test definition... The only thing that's changing is the body of the... the only thing that's changing is the actual struct, the and the hair color. So it could be like... Well, no, it's fine. We will continue for now. I think we will continue to do the same thing. So now we'll just add a pub modifier on here. You know what, I'm going to just have this so that we get something approaching, like, testing all of the permutations or what have you. And actually, well, we'll leave it on the actual struct, I guess. Coxie, I mean, changing how syntax extensions work to allow passing arguments is still useful, like, for people writing syntax extensions. So that one's easy. We just take pub any... This technically is incorrect because we're saying we take pub any number of times, but I'd rather write it that way than copying that body for a 1 token change. I mean, for it to be valid syntax following Rust in general, I would expect it to accept anything that's valid inside of a meta item, which right now is not any arbitrary token tree, but might change to something that more closely represents that in the future. I think it would make very little sense for it to not match with what works with other meta items, because that's effectively all you're doing is turning derive into a meta item, and then just have it move in lockstep with that. But like, if you want to be able to pass types there, presumably you also want to be able to pass them to an arbitrary meta item. But again, my point being, like, I feel like these aren't blocking of aren't blockers for one another if you define it in such a way that changes to meta items affect this. Because like, effectively, I feel like the change is just to specifically describe it, because right now derive only accepts meta item words, and this would change it to accept meta item words or meta item lists, but not meta item name value. But of course you could put a name value inside the list, but Okay, so that handles pub, and then let's see what happens if we make one of our fields pub. And I am almost certainly going to replace this with I'm just going to do this. I'm going to leave this one separate because I think this will be the only one that has a non-option field. Struct def probably needs to be like this, doesn't it? So this becomes like test, struct, definition. And this bothers me, how that is aligned. And this becomes the same thing, but structure this option field becomes pub. Now we can do another, which is struct with pub field. So we'll do that. And just to do this all in one compiler pass, struct with pub option field. In theory, right, if I'm going to test all the permutations, I should test it like where none of the fields are public, some of the fields are public, and all of the fields are public. But I feel like it's evident that any that any case where we are allowing more than any case where we are allowing either type of field to be public would apply to all of them, because it would be very difficult to implement it otherwise. Coxie, yeah, so like I agree with you that passing types to it is useful. My argument though is not that we shouldn't do that, but that it's a separate argument from just allowing derive to take arguments, because if it's useful for derive, it's presumably useful for other types of meta attributes as well. And I will handle restricted pub later. And yes, RFC 1575 would be helpful here. Unexpected token struct. Wait, so is it failing, like, with just a regular case? So do I have to do this? This isn't going to work if I do this as item, though. I just have to put the struct definition in here twice. I think I might. I don't think this works. Yep. Oh, I know what I can do. Yeah, we should fix that, Cuxy. That seems like a compiler issue. And not something we should ever have to care about. Okay, now let's try our other cases. That should all be failing. JS Chivink, yeah, most of it's type check, and it's also significantly longer than than usual because video encoding is taking up most of my CPU. It normally takes about 10 to 15 seconds. Okay, so that's fine. No token expected. No rules expected the token name. So it's here. We just need to allow pub, and hopefully that will work. That does not work there. So what we unfortunately have to do. Oh, well, we can just do this actually. Remove all pubs. Yeah, it'd be interesting to see if how much that affects diesel. Our main source of compiler slowness is just that we implement a ton of traits for tuples of various sizes, so we create a ridiculous number of trait implementations. Cluxy, you're preaching to the choir, man. I mean, like, custom derive is something that should, even without dealing with it in like macro form, custom derive is something that could be made stable more easily than arbitrary procedural macros, and seems like it should be, should have a nicer way to do it. Although once you start to get into things like meta attributes, then it becomes less clear how stable it can become easily, because then you get back into exposing the entirety of lib syntax. All right, is that everything for named structs? I'm forgetting things. Named fields marked with column name. Okay, so we're gonna need to not use that macro for this. Maybe we'll make this macro work later. I don't really care about hair color right now. So we're gonna call this like my name. All right. So now what we need to do here I'm going to try and refactor this to reduce some of the duplication later on. Alright, so we'll just try matching that, and I'm missing something obvious. Expected ident. I think it is because we need to handle meta items before anything else. And we're going to not put it on the actual struct definition. Okay, cool. So now we're getting to the real problem, which is that we're not separating the column name from the field name. This is a lot of duplication I'd prefer to reduce, but and what is it? What is the syntax for this? I think it's name of the struct field, colon, name of the local variable. I've actually never written this kind of this form of pattern match before. Um, yeah, that makes sense, Coxie. But I'm less logical. Alright, so we need to put an allow there so that doesn't warn. I really wish it actually included the name of the type of warning there. But, oh well. So the place we need to put it is at the very end. We actually are using the pattern allow. I'm gonna guess it's redundant pattern. If not, I will remove the deny warnings and let it, and then I think it will actually tell me. I guess I need to put it here, and those are usually plural actually. We're not going to go as long today. I'm going to try and start wrapping up by around 11, so in 30 minutes. The absolute latest I can go is 11:30. Alright, let's see what the actual lint is. It used to give like a add this allow in this error message, but it stopped recently. I don't know why. It was a very useful error. Non-shorthand field patterns. That's an awful name. So we'll also need to put the we'll also need to put the column name above the we'll need to test with the column name above an optional field because we're not handling it there. I'm just gonna go ahead and allow the duplication for now. I feel like there is probably some way that I can write this so that I handle the column name independently for like everything, and then have it look and be like after everything else. If I gave it an explicit column name, then set it, and if I didn't give it an explicit column name, then change the field name. Actually, I feel like I can do that. Whatever, I will refactor it later. Okay, this is the second one. So I need to change the first one. Foxy, if you wanna show up with some Quuxy, so the reason that we're not doing that is because we need to support tuple structs. Tabarja, not in this specific macro, but yes, the goal is that you would, if you're using something like the custom derive crate, that you'd just be able to copy paste the struct definition, or not even copy paste, but just the struct definition appears there once. So this is meant to be compatible with that. This is meant to be compatible with that crate, but we're not necessarily recommending or enforcing it, but it's just an option, and if you don't want to use it, then you just copy paste your struct definition. Struct with renamed option field. And I believe... Oh, we have one more caveat that we need to test. And that is when there is a random attribute that we don't care about, both in combination with our column name and without. Okay. what I'm going to do is I'm going to change this to not be renamed. I'm going to have a combination of both meta items on this one. And I guess I will also, no, I will still rename this. I'll test with the random attribute before and the random attribute after. So here's what we actually should do. Let's refactor a little bit before we get into this case. Let's see if we can handle just this meta attribute separately from everything else. So let's get rid of this. And what we'll do is we'll pass field name as column name. And then when we see a field that doesn't have that meta item on it, so it's field name followed by a colon, then it will be field name as field name. And I guess, yeah, we'll leave that. So then we can delete this case and this case. Because now we'll always have, wait, did I delete too much stuff? So that's, oh, I think I copied one too many times. Right, so now we'll always know this is field name as column name. Coxie, that is exactly the plan. I will have one case that just rips out the meta items one at a time, and then one case that is the correct meta item followed by n number of meta items. Why colon 112 but not 98? Because we're consuming a colon in this case, but we are not consuming the colon in this case. I could just as easily never have the colon. So I could change it to be this if I wanted to. And that'd be fine, but I just arbitrarily decide to leave the colon. Okay, so now we'll do this case, but I'll leave this one off for now. Right, so that's fine. I might actually end up just deleting a lot of these, because most of these are more to drive implementation than, well, I guess I probably will leave the vast majority of them. I might combine a handful of them, though. Okay, so after we've looked for column name here, now we're going to look for any meta item. Thanks, Coxie. Thanks for tuning in, and also for the help. Okay, now we will add one that is after. And that's just as simple as allowing any number of meta items. That occur after. Or not. Well, okay, what happens if I duplicate this so that there I allow one or more? Or am I even repeating? I think I'm repeating them correctly. And I guess this one would have to be before this case. And actually, what we can do is not care about anything else other than just stripping the ignored meta items. Debarja, no, because we still need to explicitly handle meta items which come before the one that we care about, and we can't have a repeating set of meta items followed by a specific meta item. At least I don't think so. Can we? Whoops. Yeah, no, so we can't do that. So we've got this strips, and I'm gonna start commenting these. Recognize meta, ignored meta field. Should you then also... Yes, we're still matching for that case because where we're stripping them with the we couldn't do a 0 or more pattern after. We could only do the 1 or more pattern. So we still have to have the separate case of we have ignored meta items or we don't have ignored meta items. But to reduce that duplication a little bit, the we have ignored meta items only cares about we have ignored meta items. But we still need to then actually handle our recognized meta field later. All right, and then the last case is when we have meta items on our struct. I'm not usually a fan of code comments, but in this case I am going to feel the need to explicitly comment on each of those cases because we can't give them descriptive names. Okay, so let's go through the list. Struct with pub, struct without pub, named field with no annotations, named fields with named fields were one or more annotated with column name, named fields with ignored attributes, named fields with both column name and ignored attributes, named fields with pub and any of the above. Okay, so we've completely handled named structs. Let's go ahead and comment on what each of these are doing. What the hell's the name of, I'm also going to commit here. We actually moved some stuff that I probably didn't want to move, but I will fix that later. Alright, let's quickly, I don't think we're going to do all of the modifiers for tuple structs. Fragment specifier, thank you, that is the word I was looking for. Let's quickly handle at least the simple tuple case. And I want to refactor these tests to be less duplicated, but we're short on time. And probably what I just actually need to do is have this stuff get pulled out into a function. Anyway, okay, so simple tuple structs. Oh, no, you know what? We're not going to get to tuple structs today. We need to handle lifetimes. So let's go ahead and do... What am I looking for? Also, this test says with renamed option field, but that field is not an option. We should make sure that that works. And then I'm going to go ahead and do this. And we actually want to pass none here and expect green back. We'll do the same here to make sure that it is actually handling option properly. Okay, and that's what we expect. I almost just want to do this. I'm not sure if we can do this. Meta items, pub. Definition. Right, so that way we just don't have to duplicate, like, the code to strip that out. And now we can match against just this. And then if we have lifetimes, those are going to be separated by a comma. Yes, Nate, this I should rename this entire module from macros to Trump. Okay, and then the last thing we need to do is modify our where clause so that we also specify that the lifetimes outlive insert. Or that... I believe we want to specify that lifetimes outlive insert, but in this particular case, I've actually found that I've needed to do the reverse. Let's see, I think it's insert lifetime. Yes. I mean, this macro has gotten huge. Like, it's just because I'm basically trying to do procedural parsing here, but I can't actually have some of these concise conditionals. Or really, if I were doing this in a procedural macro, right, I have data structures that have meta items like as a property and visibility as a property, and I just don't access that property if I don't want to because I'm not parsing it. I'm just dealing with the AST. But here we don't get to deal with the AST, we get to deal with the tokens. Okay, now that works. And so this is what I mean, where it's like, I'm pretty sure there's some bug here somewhere, because if I'm reading this correctly, this is saying where insert outlives each of those lifetimes, which is incorrect. We're saying where the lifetime of the struct is longer than the lifetime of the data inside of the struct. That is exactly the opposite of what we would want. So I'm not sure why it wants this constraint. I feel like there is definitely some bug with relation to. I think this is the same as when we use the type alias, how it also gives a similarly nonsensical error message, but inlining the type alias works fine. I think it has to do with how self values gets inlined here. Because if we reverse this to what it should be, where lifetime outlives the lifetime of the struct, right, we're gonna get an error. Yeah. Maybe I'm doing this wrong, because the error message is implying what I would imagine I need to say, which is that the data lives at least as long as where the data outlives the lifetime of insert, which I believe, unless I've got this backwards, my understanding was this is saying where insert lives at least as long as the data, not that the data lives at least as long as insert. Anyway, okay, so now we're handling lifetimes. It is 11. I don't think we will finish tuple structs in the next 30 minutes if we start on them now. And we didn't need to change our parsing of the fields to deal with lifetimes because we just don't care. Because it only affects the actual type of the struct itself. So I think that's going to wrap us up for today, guys. Thank you all for tuning in. If anybody has any questions, feel free to ask them now. I will probably be streaming again on Tuesday afternoon. 3 p.m. Mountain Time. I believe that is 9 p.m. UTC. If you have any feedback, please let me know on Twitter. My username is SGRIF. And I will probably finish this up to handle tuple fields this afternoon. And then I will open the pull request. But I need to. One of the things I want to do is look at how the custom derived crate appears to be using higher order macros. Because what I'd like to actually do is all of this struct parsing stuff, moving that somewhere independent. Because the attributes that I care about are the same for all of our custom derive. So that would be a useful thing to reuse. Maybe I actually still can. I'm not positive. Anyway, yeah, so that's gonna do it, guys. Thanks for tuning in. I'll see you next time.